Hi everyone, Mrs. Musoff here, and today we're going to be talking about conditional probability, and we're going to do that through the use of two-way tables. Okay, so just to give you a definition, conditional probability is probability that meets a certain condition, a certain given condition, we should say. Probability that meets a given condition. For example, instead of the probability out of everyone, it's the probability out of just the seniors, or out of just the girls, or whatever the case may be. So what it basically does is it reduces your sample space. So instead of looking at everyone, we're looking at just a portion of the population. Alright, so it changes your denominator. So instead of out of all 100 people, you're only looking at 57 of them, whatever the case may be. And you'll see sometimes we write it in words, and we'll talk about that in a little bit, but sometimes we use this notation, and the notation is this vertical line here, which means given. So what this actually is describing, it's saying find the probability of A given that B is true, or B already happened, right? And the general way, if you need a formula to do this, is going to be to find the probability of both happening and divide it by the given part, the part we already know is true. But we're going to go through some examples, and hopefully you won't need to use the formula. It'll just kind of make sense as to how to set it up. Okay, mostly this conditional probability comes through the use of two-way tables. And two-way tables is just a way to organize information from two different sets of categories. For example, down here, the table below shows the results of a survey of people who are in the marching band at school. And they're divided into two categories, grade and gender. So you put grade as one set of categories. Oops, that is not where grade goes. As one set of categories. So here are rows. And then you put gender as the other set of categories. Here are columns. And every time we do a table, we usually, and by usually I mean always, want to put our total numbers down also. Because we're going to be using those, so we might as well write them down right at the beginning. So total males, I'm going to add these together. That's 68. Females is 32. Juniors is 42, and seniors, 45 and 13, so 58. And all together, we have 68 plus 32, that's 90 and 10, so 100 total people surveyed. And usually those are some of the first questions we answer. So here, how many people are surveyed? 100 people. How many juniors? So that's my total for juniors, which is 42 juniors. And how many females? My total for females is 32 females. Okay, then we get into the nitty-gritty of the probability. Okay, so some of these are not going to be too bad. For example, it says a student from the survey above is chosen at random. Find the following probabilities. Probability is male. Well, because they didn't give us any required, like this condition has already been met, we know we're looking at everyone. So I'm going to put this out of my total 100 people. And then if I want to know the probability it's male, the numerator, the top, should be the number of males that were surveyed. And here, if I look at males, 23 and 45, that would be 68. So 68 out of 100. And you could leave this, you could simplify it, you could give me the decimal and divide it by 100. Decimals are kind of easy, so whichever you want. Okay, same kind of thing in E. So the probability that they're male and senior. Again, we're still looking at everybody, so still out of 100. But now I want the probability they're male and senior. And will always mean both. Or another way to think of it is the overlap. So it's where males and seniors overlap in my table. So one thing I like to do is I like to, using my highlighter, I'll highlight my male. So right here are the males. And then I'll highlight, male and senior. So I'll highlight seniors. And should be where those two highlighters overlap. So in this case, on that 45, you can see how it's green. That's where they overlap. So my numerator would be 45. There are 45 males and seniors. And again, I could leave it. I could simplify it. I could write the decimal. Up to you. Okay? Try it again with F. Probability it's female or senior. Now, or is a little different because remember, or means add. And in order for an or statement to be true, you just need the number to fall in at least one category. So, at least one. Meaning it doesn't have to be both. It doesn't have to be the overlap. It just has to fall in at least one. So again, I'm going to do the highlighting thing. Let me erase what I had. So this is female or senior. So I'm going to say, all right, here are females. And here are seniors. But this time, I'm not going to just pick the overlap. I'm going to pick any number that was highlighted, even if it was just by one color. And I'm going to add them all up. So here I would take the 19, the 13, and the 45, and I would add them all together. So basically, the only one I'm not including is 23, because it's not female and it's not senior, so it doesn't count in this. So 19 plus 13 plus 45. And it's still going to be over the total 100 because we haven't said anything to change that. So I would add this up. Let's see, 32 and 45 is 77 out of 100. And again, you could keep it, or you could do the decimal, up to you. Okay, same kind of thing in G as we did in E, probability female and junior, and still means both, which is where they overlap. So I'm going to erase what I had here before. Female and junior, so here is female, here is junior, and is just the overlap, so that would be the 19. And again, nothing's changed my sample space, so it's still out of 100. Okay, then we start to get into the examples where our sample space changes, and it's when you see that given bar. Because what this is saying is, what's the probability it's a female given that we already know they're a senior? So that means that instead of putting out of the total 100, I should only be looking at seniors. So something I like to kind of do to help me here, since I already know it's a senior, I'm going to cross out this whole junior column. I'm only looking at my seniors. And so that means my total would be 58. And of those seniors, I want to know how many are female. So I would say, all right, female, that's 13 of those 58. So I'd put 13 over 58. And I could get the decimal, or I could just leave it up to you. So basically what this means, this line means given that, and it means put the seniors on the bottom. So change your denominator. All right, same kind of thing with letter I. Probability it's a junior, given that we already know they're male. So again, the male is going to be the bottom of my fraction. So how many males are there? Well, let me erase this. So now I'm just looking at males, so I'm going to cross out females. So males, there are 68 of them. And out of those 68, I want to know how many are juniors. That would be 23. And again, give the decimal or leave it as the fraction. Just make sure in these problems you're always at the bare minimum giving me the fraction so that I can clearly see your work. Alright, if we move on, the only extra piece we might do is we might have you create your own table, which is what we're doing here. And the one thing I'll say with creating your own table is you have to be really careful to read things very closely, because it could be a difference of like 2 words that could change where you put numbers. Alright, so just be really careful. So here, for example, Philippe surveyed students at his school. He found that 78 students own a cell phone and 57 of those students own a tablet. So I can sense kind of 2 categories forming, cell phones versus tablets. And especially later where it says there are 13 students that do not own a cell phone. That means we need to set like a row or a column for owning a cell phone and for not owning a cell phone. And it looks like the same kind of thing for tablet. We know numbers for owning a tablet and then for not owning a tablet. So that's how I'll set up my categories. I'll say like cell phone, and then no cell phone, and then tablet, and no tablet. And then you just have to be really careful that you put things in the right spot. 78 students own a cell phone, so that's like a total for cell phones, because it didn't specify tablet or not tablet, so I'd say cell phone, that's my total, 78. And then this is where it gets tricky. It says 57 of those students. So of the 78, 57 of them also own a tablet. So now I'd put 57 here. And then just by subtracting, we can get this number here, right? 78 minus 57. That'll be 21, so that'll be the number there. All right, same thing with the next few sentences. There are 13 students that do not own a cell phone, but own a tablet. So no cell phone, yes tablet. And then there are 9 students that don't own either device. So 9 for no and no. And then I should be able to find the rest of my totals. 22, that's 70, and 30. And my overall total, I'll just add 2 of these totals up, 70 and 30, that's 100. So 100 total students. All right, now let's try the wording. So find the probability that if a student is selected at random, they own a cell phone and a tablet. So this is a both situation. So again, I'm going to put it out of my total 100, but I want only the overlap. So cell phone and tablet. The overlap is 57. So I'd say 57 out of 100, or 0.57. Okay. Find the probability that if a student who owns a tablet is selected at random. So now we're changing the denominator. We're only looking at students who own tablets. It's like our given. So instead of out of 100, I'm going to say own tablets. That's 70. And then I want the probability they don't own a cell phone. So of those 70, 13 don't own a cell phone. So we'd say 13 out of 70. All right, so with words, you just have to kind of read it really carefully. For part C, find the probability a student selected at random doesn't own a tablet given that they own a cell phone. So again, we're being given information. So instead of out of the 100, I want only the people who own cell phones. And cell phones right here, that's 78. So I'd say out of 78. And then we want the probability that they don't own a tablet. So 21 of those don't own the tablet. And so that would be my fraction. Okay. Part D, find the probability a student selected at random owns a cell phone. So now there's no given information, so it's out of the 100 again. But this is just owns a cell phone in general. So that would be the 57 and the 21, which would be 78 total. So 78 out of 100, or 0.78. All right, and that's the idea of this. Number 5 is similar. We're just trying to fill out a two-way table. So again, I'm going to get it set up, and then I'm going to read it really carefully. So here's, and I always like to put my totals in there. So it says you randomly surveyed students in the school about whether they were attending the big homecoming game. You surveyed only juniors and seniors. So right there I can kind of get my categories. I've got juniors and seniors. And then I surveyed about whether they were attending the game. So either they're attending or they're not attending. And then I can start filling in my numbers. Okay, 42 juniors plan on attending. So juniors attending, that'd be 42. 77 seniors plan on attending. So seniors attending is 77. And then there are a total of 106 juniors you surveyed. So total for juniors is 106 and 114 seniors. And then just by subtracting, we can fill in our missing pieces here. 106 minus 42. So that should be, let's see, 64. And 114 minus 77 should be 37. And then if we add straight across, we can get our final totals over here. So 119 and 101. And then our final total, just add 2 of those total numbers, so 220. Alright, so just make sure you're reading these problems carefully. If you have any questions, just write them down. Thanks for listening.